Hello, in this recording we're going to talk about disk layout. Now, while the layout of the disk is always going to be the same, you can create partitions of varying sizes for individual purposes, and the LPI exams want you to kind of have a basic understanding of the different ways you could do that. So we're going to cover that in this video. Now, the first petition is obviously going to be the root petition, and anything else that you mount to the system is going to be mounted off the root petition somewhere. Now, it is possible to have one really large root petition, but you're generally not going to have just a root petition. At a bare minimum, you'll usually have a boot petition as well. Especially with EFI, you really want to have a boot petition where you're going to keep EFI has certain images that it uses, and you'll put that on the boot petition. And you'll usually have it as a VFAT file system if you're using EFI, so other systems can put images into that. Usually the boot petition is about 500 megabytes in size, and obviously your kernel images and your init RAM, FS, and and the grub bootloader, things like that would go in /boot. So I guess these days, if you're automatically petitioning a system, a lot of systems will give you boot petition, and then they may give you one really large root petition for the rest of the system. Now, if you're going to go in and lay the system out yourself, you may want to create a custom size for the home petition. So the home petition is where all of the user data is stored. So all the different user data files for the files that they save on the system would go into /home/ their username. The other reason you may want to have a dedicated home petition is if you wanted to use disk quotas to limit the amount of space that users could use. If you're in a large office environment, or if you're in a university or something like that, and there's a Linux system that stores all of the data, then obviously with thousands of users, you're going to want to limit how much each user can save into their home directory to make sure there's enough resources for everyone. So if you wanted to use disk quotas for the user data that gets saved, you could create a custom home petition. Now, SRV is not used by CentOS and Red Hat at the time of this recording, but it's where service data would get saved. So web servers and databases and mail server data and all that sort of stuff would get stored in /SRV. So if you're laying your system out so things are stored in that location, you may want to have a large partition for that so it doesn't run out of space. Now, /USR is not one that you would generally have a dedicated petition for, but that's where all of the program files are saved. Like the binary files are in /USR /bin, the documentation /USR /share /doc. So usually if you would have that as part of your root petition. So if you wanted to have just the user data and stuff on the root, just like binary files and system files, then and stuff like that, you might have a 5 gigabyte root petition which includes /USR for just all the system binaries and documentation and stuff like that. Now, the /var petition is variable data. So Red Hat and CentOS based systems would use that the same way as SRV. So you would have your log files, you would have database document roots in there, you'd have the spool files for mail and printing and all that sort of stuff. So you may have a dedicated petition for var. So that you're limiting the data for that, so it's not going to fill up and end up taking up all of the system. Now, if you wanted to know more about what all the different directories on a system does, there's this thing called the File System Hierarchy Standard. And it is for basically Unix-based systems to have kind of a standard between them all. So it's useful for developers to know where files are going to be if they're writing software. It's also useful for users and system administrators to know that no matter what system they're on, they can expect a fairly consistent layout of this file system. Now, there's also the Linux standard base, and it basically will tell you what files should be on a Linux system, like what programs and what kind of environment developers should expect for, so when they create applications, see it says here it reduces the cost of porting applications, so application developers can kind of know, well, if I'm on any Linux distribution that closely resembles the Linux standard base, then my application should work because these applications would be present. So the Linux standard base is something else you may want to look into. Now, I also noticed that the Linux Foundation have created a specification for the file system hierarchy version 3, where the pathname.com, which is traditionally where it was stored, it only has up to 2.3 at the time of this recording. So I don't know whether they will update that at some point, but the Linux Foundation have actually updated the specification on June 3rd, 2015. So there is a new version 3 standard that you could look at, which is created by the Linux Foundation. So I guess that is optional, like knowing this stuff here isn't part of the exam. I just thought that I would include it, so if you wanted to go and, I guess, do further reading on your own, that you have the knowledge that stuff exists, so you can go out and do that. So I will end the video there, and I'll see you in the next one.